All right, guys, here we go. Note 17, trig identities and some cool stuff. All right, it's pretty much a continuation of note 16, guys. So let's go ahead and continue. So what do we know right now? This is called, well, we call it the Valentine's formula, but in actuality, it's a Pythagorean identity. If you put Pythagorean identity, you might get like a Pythagorean theorem. So put in Google, type in trig Pythagorean identities, and this one will come out. That will probably be the first one that comes out. And you can rearrange this to look like this or this. All you got to do is, if you want to get cosine squared by itself, move the sine squared to the right, and there it is. So all three of these guys are the same identity. It's just transformations. Yay or nay? All right. Same thing with this, guys. This was the second trig identity that we found, and all I did was I took the Valentine's formula and we divided it by cosine squared, and that's how you get this new property. And of course, if you move the tan squared to the right, then 1 equals secant squared minus tan squared. If you leave the tan squared like that, and if you leave the tan squared where it's at, or leave it, just don't touch it, and move the 1 to the other side, then you get tan squared is equal to secant squared minus 1. And of course, you can do, so there it is. All three of those are the same. And the same thing with cotangent. Not a big deal. I think we're okay with all those, I think. All right. What is the even function? What is the odd function? And why does this matter? So when you guys were in Algebra 2, you remember when you guys talked about even functions? If you had a parabola and its vertex was right on the y-axis, it was an even function. Why? Because it was symmetric about the y-axis. Now, the technical definition is this. This is even. And the technical definition is f of negative x equals f of x. So what has that property? Well, let's see. Cosine has that property. So cosine of negative theta equals cosine theta. If cosine has that property, then that means the reciprocal of cosine also has that property. Secant of negative theta equals secant theta. And I can see some of you don't know what I'm talking about, or at least, I don't know, maybe I'm misjudging, but here's what I'm talking about. If I tell you what is cosine of pi over 6, you would tell me square root of 3 over 2. If I tell you what is cosine of negative pi over 6, you would also tell me square root of 3 over 2. See? So that's what I'm talking about, guys. It has that property there. Okay, that's, by the way, I don't know if you'll make this connection or not, but this is why we put plus or minus when we're doing arc cosine. Arc sine does not have plus or minus. Arc sine has a pi minus whatever, right? All right, so what is an odd function? An odd function is symmetric about the origin. That means it must go through the origin. So when you guys were in Algebra 2, y equals x cubed is an odd function because it goes through the origin. But y equals x cubed plus 1 is not an odd function, even though x cubed is an odd power. It has odd function behavior, like, as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity. Stuff like that. And behavior, you guys remember that? No? Okay, maybe I'm talking too much. Okay. But just know the difference, guys. This one's not odd. X cubed plus 1 is not odd. It has to go through the origin. Now, what does it mean, symmetric about the origin? So let me write that down. Symmetric about the origin. Okay, let me tell you what it means. I remember having a discussion with a PhD in math, and she was like, I don't like it, but I guess technically you're right. I like to call it flip-flip. If you go to your professor and you go, yeah, flip-flip, it's odd. Your professor might be like, flip-flip, like, who tell you that? And don't mention my name, just say Jeff High School or something, When I say flip-flip, here's what I'm saying. You see this part that I'm putting in black? If I flip it, it doesn't even matter what axis. If I flip it, whatever axis you want, let's flip it against the x-axis, then that in black would be over here. And then when I flip it again, that in green, flip it with the other axis you haven't used yet, the y-axis, that in green will turn into this one in blue. Does that make sense? So flip. So that's why it's symmetric about the origin there. So, yeah, so flip. And I'll put that in quotes. Flip. And it works. All right, so here we go. And by the way, because of the flip, it must go through the origin. If it doesn't go through the origin, it is not technically an odd function. You can have odd function behavior, but it's not an odd function if it doesn't go through the origin. Cool or not cool? Cool. All right, what's an odd function? Well, let's see. Sine. Oh, by the way, this is the technical definition. Just like even has this definition, the odd has this definition. F of negative x equals negative f of x. So, what has odd function behavior, or what's an odd function? Sine. Sine of negative theta is equal to negative sine of theta. And if sine is odd, then that means the reciprocal of sine is also odd. Cosecant of negative theta is equal to negative cosecant of theta. Let's see, what else is odd? Tangent of negative theta is equal to negative tan theta. And then cotangent negative theta is equal to negative cotangent of theta. 1, 2, 3, 4, 5, 6. We got them all. You feeling all right? Okay. What about when sine, cosine, tangent are squared and I have a negative argument? So that means this. What if I square sine and I have a negative argument? Well, because you're squaring it, negative times a negative will always be a positive. So this is equivalent to sine squared theta. Now, I don't want you to think that you're squaring the theta, guys. Let me give you an example. And this is actually true to all. True for all. True for all. For all the trig. Child, what do you mean? That means this. Tan squared of negative theta is equal to tan squared theta. And then for the cosine, doesn't matter because it was an even function anyways. Cosine squared negative theta is equal to cosine squared theta. That's a square there. And let me give you an example. So everyone knows, or at least I hope, because we haven't done unit circle quizzes in a while, but everyone knows that sine of negative pi over 6 is a negative half. Right? Because, okay, I'll draw a unit circle real quick right here. Negative pi over 6 is right here. Remember that sine is a y value. Square root of 3 over 2, comma, negative half. Everyone knows that sine of pi over 6 is a positive half. Right? But let's see. Let's square it like we have here. So I'm going to write sine squared of negative pi over 6 equals sine squared of pi over 6. So I'm just going to put what the statement is. And I'll slow down. Sine squared. So what you're squaring is the sine. Sine of negative pi over 6 is negative half. So I'm going to write negative half, and I'm going to square it. Equals, and then this one was a positive half. Positive half, and I'm going to square it. Hopefully it already looks like a true statement. You can already see it is a true statement. Negative half squared, negative times a negative is a positive. So there it is, 1/4. And on the right-hand side, 1/2 times a half, as again, is a 1/4. Does 1/4 equal 1/4? Check mark. Yeah. So you can see it always works. I'm just proving it to you guys that it works. Yay or nay? All right. Perfect. I think we're good. We're doing good timing. You guys are super smart. All right. What identities should you know codes? All the reciprocals. All the reciprocals. That is, let me give you an example. Example, you should know that cosine theta is the same thing as 1 over secant theta, and vice versa. Secant theta is the same thing as 1 over cosine theta. So know all the reciprocals, stone cold. Like, know it like the back of your hand. What else should you know? You should definitely know that cosine squared theta plus sine squared theta is equal to 1. That's the Valentine's. Know that one cold. Know that one stone cold. What else should you know? That cosine and sine repeat every 2 pi. So if I write theta plus 2 pi, bless you, that is the same thing as saying cosine theta. Same thing with sine, guys. Sine of theta plus 2 pi is the same thing as sine theta. That actually might apply to all of them. But be careful. Tangent. Tangent actually repeats every pi. And I'm kind of tempted to write pi n, and then maybe I should have written a 2 pi n there, where n is any integer. If n equals 2, where n is any integer, n is any integer. So you can have a 2 pi, 3 pi, 4 pi. I didn't even say what it equals, right? I just wrote that. That equals, man, this is so funny. Sorry, guys, I'm laughing because I'm thinking like someone would look at these notes and they're like, what is tan? Like, what is it? Like, okay, I'll stop. I'll stop. Tan theta. Tan theta plus pi n is tan theta. Always. Where n is any integer. There. Now the notes are much better. At least know all that stuff, guys. Hopefully you've been in this class long enough that all this is borderline like getting really simple for you. Like where it's like, yeah, that's all like stuff, common knowledge. I already knew that. So hopefully it's stuff that it's not that bad. All right. Last but not least, and this I guess is kind of borderline common knowledge, but maybe sometimes we don't see it. Cosine and sine just differ by pi over 2. They do. They just differ by pi over 2, guys. So if I take my calculator, so look, check it out. Let me take my calculator, and don't worry, what was I going to say? I'll put back the notes in a little bit. I would use Desmos, but my internet connection has been kind of weird lately. So here's cosine and sine. They only differ by pi over 2, which hopefully you can tell which one's cosine and which one's sine. This y-axis here is right here. That's 0. So the blue line is the cosine, and you can tell there's blue right there. And the red line is the sine. If I move the red line or the red curve, because it's a curve, if I move the red curve 90 degrees to the left, it will be exactly where the blue line is. If I move the blue curve 90 degrees to the right or pi over 2 to the right, it will be exactly where the red is. Does that make sense? So because of that, I can do this. I can say this. Cosine theta is equal to, and I'm just going to shift it, pi over 2. So it's equal to sine pi over 2 minus x. Same thing with sine x. Sine x. Oh, I brought an x and I wrote a theta, so I need to be consistent. Theta. Sine theta is equal to cosine pi over 2 minus theta. That's all it means. Let's check to see if it works. Let's check to see if it works, guys. So I'm going to come over here and let's see. Cosine. What am I going to type? Okay, I should have left it as cosine x. And then in the bottom, I'm going to type in pi over 2 minus x. So I'm going to put alpha pi over 2 minus x, close it, and I'll check it out. Oh, okay. Yeah, that's fine because it's pi over 2 anyways. So I'm going to push graph, blue and red. So it's going to go fast. There's my blue curve. There's my red curve. Did it overlap? Yeah. Look what happens. Oh, look, there's an easy hack. I'm just going to put sine here, and I'll push cosine, and I don't have to mess with any of the buttons. So now look what happens, guys. There's my blue one, and look, OMG, there's the red one. It overlaps. Cool, right? Okay. You have all the tools now. Happy face. You have all the tools now to do questions like this. By the way, I don't know if the exam is offered anymore. If you love what we're doing, it's called the ACT Math Subject Exam Level 2. It has a whole bunch of trig, and it's all of this, and you can score really high because it's just this. I don't know if they still offer it. I think they stopped offering that exam 2 years ago. But if they still offer it, I would register for it so you can prove colleges that you know trig. All right, here we go. Which of the following is equivalent to blah? Well, here's what I would notice. Look at your answer choices first. There's only one answer choice that has a negative argument, that has a negative in the parenthesis. So it's probably going to be a positive theta. So then I start looking at this, and I remember sine is an odd, and cosine is an even. So that means sine of negative theta is equal to negative sine theta. And that means that cosine of negative theta is equal to cosine theta. With that knowledge, and I'll slow down. With that knowledge, I'm going to write sine negative theta over cosine of negative theta is nothing more than negative sine theta over cosine theta. And I look, and I don't see my answer there yet, but it is in there. And I'm like, oh, okay, well, it's not sine over cosine, but what is sine divided by cosine? Tan, so I put the negative back in there, and I just write negative tan of theta. And I look for that. Is that answer in there? Yeah. I don't know why it took me. How do we feel? Nothing crazy, right? All right. Here we go. Cosine tan. All right, on this one. So you're looking at the answer choices. You're looking at the cosine squared, 1 plus sine theta. Okay, guys, in your head, here's how you should be thinking. As soon as you see something with a square, I guess you can. Okay, I know I'm jumping all over the place here. You probably can multiply this by the conjugate of 1 plus sine, and something will happen there. You'll get 1 minus sine squared, and you can replace it. But here's what I see first. I see that square there, and as soon as I see a square, I'm like, I know that all of them, if they're squared, means something. All of them, because look at the front page. All of them have a square on them. So I know if they have a square on them, I can make it look like something. See, I'm looking at 1, 2, and 3. You guys see what I'm talking about? So here's what I'm going to do. I'm going to write right here the Valentine's formula. Cosine squared theta plus sine squared theta equals 1. And I'm going to move the sine squared to the right because I want to get the cosine squared by itself. So cosine squared theta equals 1 minus sine squared. Well, now that I have that, I can just do a substitution. So substitute this in for cosine squared. So you have 1 minus sine squared theta over 1 plus sine theta. And here's where it gets to be a lot of fun. Well, if you love algebra, it's going to be a lot of fun. Right, Salazar? Okay. All right, here you go. Ready? I know, I'm getting better, guys. I can see you guys still writing. Okay. The numerator is the difference of squares. Now, maybe you forgot about it, so let me make a side note. When you have two numbers that are squares, if they're perfect squares, you can, we're in high school. We'll leave it at that, because everything can be a difference of squares. But at the high school level, let's talk about perfect squares. This is the same thing as a plus b times a minus b. Do you guys remember that from Algebra 2? I was going to say high school, but we are in high school. Okay. So this in the numerator is a perfect square, guys. 1 times 1 is 1. Sine theta times sine theta is sine squared theta. So I can rewrite the numerator as 1 plus sine theta, 1 minus sine theta, all over 1 plus sine theta. How do you feel? Okay, awesome. What can I cancel? If it helps, put parentheses on this. Yeah, the 1 plus sine theta, they cancel out. Look, bam, bam. What are you left with? That's my answer. Beautiful, beautiful. If you like puzzles, you will love this, because this is just like a little puzzle. That's all you're doing. Do little puzzles for fun. All right, here we go. Example 3. We'll go slow. Don't worry. No, yawn. That's a demerit. So I see cosine x plus 2 pi. I see sine x plus 2 pi. And I know that every time I add 2 pi, I'm going to be in the same location. So this is the same as cosine x over sine x plus, and then this one is the same as sine x over cosine x. And I believe this was actually part of your activity last time around. Now when I add those two fractions, I can't add them unless I have a common denominator. Multiply this one by sine x over sine x. That's like multiplying by 1. And multiply this term over here on the left-hand side, by cosine x over cosine x. Make sure you put cosine x over cosine x, because some of you have the habit of just writing times sine x and times cosine x. Don't do that. It needs to be a 1. It needs to be a numero uno. It needs to be a Juan. It would be funny if we had a kid named Juan in here, but we don't. Anyways, here we go. Sorry, YouTube. I know my jokes are lame. Cosine times cosine. What is it? Cosine squared x. Oh, why did I go to blue? I tried to push red here. Cosine squared x over, and I'm going to write it as cosine x sine x plus sine x times sine x. Sine squared x over cosine x sine x. And yes, you could have done it in one. You don't have to do it like this. Are my denominators the same? Yes, combine them. Cosine squared x plus sine squared x, or make it 1, right? All over cosine x sine x. What do you see? Do you see the Valentine's formula? What is cosine squared plus sine squared? 1. 1 over cosine x sine x. And don't give up. Chop, I don't see that answer. It's in there. It's in there. Just go 1 over cosine x times 1 over sine x. That's equivalent. That's the same. What's 1 over cosine x? Secant x. What's 1 over sine x? Cosecant. Is that answer in there? There it is. How do we feel, guys? Last one. Last one. Okay. When you look at questions like this, don't get intimidated. Have we ever dealt with a cubic, a cosine cube? No, we have, but not the way we've done it the last week. So immediately you should be like, well, I guess I can write that one. So I'm focusing on this term right here. So I guess we can write that cosine cubed as cosine squared x times cosine x. Does that make sense? So you got to know algebra also, law of exponents. Cosine squared x times cosine x is cosine cubed, right? All right, and we're going to do a hack, just like what we did last time. Right now I'm just focusing on this right term. I know that cosine squared x is 1 minus sine squared x. That's fresh in my brain because we just did it a little while ago. We just did it. It was the last one that we just did. So cosine squared is 1 minus sine squared. And I know that 1 minus sine squared is the difference of squares because we just did it. See, all this is by design intentionally, guys. I created these notes, by the way. Okay, anyways, sorry, guys. So, yeah, I put a lot of thought into how I write it. I really do. So here we go. So I'm just focusing on this term. I'm going to write it like this. 1 plus sine theta over, and I'm going to write this bottom one. I'm going to write it like this. I'm going to put in 1 minus sine squared for cosine squared. Put it in parentheses. 1 minus sine squared theta times, and this one, cosine x. In case you're wondering what came from what, this cosine is that cosine. And cosine squared, remember, is 1 minus sine squared, and that's what I replaced for that. So there it is. Everything's nice and linked. So hopefully all the notes make sense with arrows and everything. Are we okay so far? All right. We know that 1 minus sine squared is the difference of squares. And look what I can do. I'm just working with that. I'm writing 1 plus sine theta as the numerator. In the bottom, I'm going to write 1 plus sine theta times 1 minus sine theta. And then I still have that cosine x. Or cosine, that should be a cosine theta, huh? So, sorry guys, replace the x with a theta so we can be consistent. Cosine theta. Are we still okay? What's going to cancel? The 1 plus sine theta. Bam! Now we're working with something. So here we go. So let's restart. So I'm going to put restart. And I'm going to write my whole sequence. So I have secant theta over 1 minus sine theta minus, and now I just have 1 over 1 minus sine theta, parenthesis, cosine theta. So get up to here. Now, okay, catch up to here. There is so many things we can do, so many things. I am tempted to rewrite that secant theta and just slide a cosine theta to the bottom. But I don't know if that comes with experience. The more you do this, I think what you guys would probably do. Here's what I'm thinking you guys would probably do. You guys are seeing this, and you guys would probably say, "I need a common denominator." I think that's what you guys would probably say, right? So that's fine. I need a common denominator. Notice that both of these terms, and I call them terms, one on the left, one on the right, the quotients. Notice that they both almost look like they almost have the same denominator, but this one on the left is missing a what? Cosine. So I'm going to multiply this by cosine theta over cosine theta. So here we go. I'm going to write it like this. I'm going to write cosine theta secant theta over 1 minus sine theta cosine theta minus 1 over 1 minus sine theta cosine theta. They both have the same denominator, so I'm going to write it as cosine theta secant theta minus 1 over 1 minus sine theta cosine theta. So catch up to there and let me zoom in. And then you look at your answer choices and you're like, that's not in there. Chav, you're wrong. It's not in there. Okay, and I'll wait. I see some of you still writing. It is in there. Cosine and secant are reciprocals of each other. So let me write what that means in the side note. Side note, cosine theta is 1 over secant, and secant theta is 1 over cosine. It doesn't matter which one you replace. If I replace the secant with 1 over cosine, or if I replace the cosine with 1 over secant, something's going to happen. They're going to what? They're going to cancel each other out, right? Do you guys see it or no? Look, I'm going to go ahead and replace cosine with 1 over secant. So look, 1 over secant times secant, that's the numerator, minus 1 all over 1 minus sine theta times cosine theta. That's the times, that's a little dot. See, that's like secant theta over 1, guys. This cancels out. 1 minus 1 over 1 minus sine theta times cosine theta. What's 1 minus 1? 0. And 0 divided by anything? 0. Oh, that's a cute smiley face. So this answer is 0. Does that make sense to you guys? Okay. All right, so here's what I want. And look, we finished in record time, 2:45. That means you guys have a whole hour. That's good. All right, so here's what we want. We have a whole hour, and relax. I want an attempt on a UH quiz, on this UH quiz today. It's called UH Trig Identities 1. And let me talk, before you get your laptops out, let me talk real quick about it. I'm considering taking this as a test grade. When you take it, guys, what was I going to say? Oh, yeah, when you go the first time through it, guys, I want it to be like your attempt, so don't ask me questions while you're live. Ask me questions after the fact, like which ones you don't know how to do. You can take it as many times as you want, but I do want the first attempt, I do want to see in the log, because, you know, everything's recorded. In the log, I do want the first attempt to have the time slot between 2:45 and 3:40, between now and 3:45. I want the start time to say sometime between now and then. There's only 12 questions, so it's not as tedious as the others, because remember the others with 20, 21 questions is like, oh my God, I can't, like, I don't want to take it again and again and again. There's only 12, so you're not going to feel tired. Matter of fact, you'll probably be done in 20 minutes. So yeah, what do you guys think? Is that okay? All right, now I want to be fair, so I want to make sure that everyone agrees. If I'm going to count this as a test grade, I really do want you to get 100, because I'm trying to get averages high. I'm trying to help you guys out. I want to say 1 week should be enough to get that high grade. So I'm assigning it today. It will be due next week. Is 1 week a fair enough amount of time to get the highest grade possible? All right, so no one's gonna say like, oh, I didn't know, or I didn't get a chance to take it, because 1 week is a lot of time, right? All right, so we have 1 week to perfect it. I want the attempt date today, and that's it, guys. We're done. Good job. You guys did a good job. If I had pyrotechnics, I would push the buttons now and